Hi everyone, we're going to talk today about infinite series, and a series is the sum of a sequence, the sum of the terms in a sequence. Okay, so yesterday we looked at a bunch of different types of sequences, and today we're going to look at specifically the sum of a geometric sequence. Okay, so for a geometric sequence is like a multiplying sequence. So for example, you might have something like this. Okay, let's go with 5, 10, 20, 40, 80, that kind of thing. Okay, and the idea is that when you go from one term to the next, you multiply by the same value. Okay, so this is something that you would have looked at in grade 11. The general term for a geometric sequence is this: Tn equals a times r to the n minus 1. A is the first term, and r is called the common ratio, which is that value that you keep multiplying each term by. It's called the common ratio because it's the same ratio from one term to the next. Okay, so if I look at the ratio from 80 to 40, it's the same as the ratio from 40 to 20, and the same as the ratio from 20 to 10, etc. Okay, so for this, for example, Tn would equal 5 times 2 to the n minus 1. Okay, so for example, 1, 2, 3, 4, 5. T5, which is 80, would be 5 times 2 to the 4, because n minus 1 would be 4, right? Which is 5 times 16, which is 80, which is what we got. Okay, now a series is when we add the terms together. So if I wanted to look at S5, for example, I would have to add T1 plus T2 plus T3 plus T4 plus T5. Okay, so I'd add 5 plus 10 plus 20 plus 40 plus 80. Okay, so that's what a series is. It's the sum of the terms in a sequence. Okay, now some series actually have, some infinite series have a specific sum, and when they do, they're called convergent, and some don't, right? For some series, the sum is actually like infinity. Okay, now the ones that have a sum that are called convergent, the common ratio from one term to the next must be, or the absolute value of that common ratio, I should say, must be less than 1. Okay, so if a series is to converge, if a geometric series, the sum of the terms in a geometric sequence, is to converge, that common ratio, the absolute value of that common ratio, must be less than 1. So if we look at these two examples, here's a geometric sequence where if I look at the terms here, my first term is a half. Sorry, not, that's my first term, A. It's also T1, but A is a half. And then if I look at what am I multiplying each term by, I'm actually, R is also a half, right? I'm multiplying those by a half as well, okay? So because this common ratio is less than 1, then this is going to converge, and I'm going to have a specific sum of the entire series. And that sum, this is also something that you looked at in grade 11, is equal to A over 1 minus R. Okay, and that's true for any series, geometric series that converges. So in this case, the A value is a half over 1 minus a half. So that's a half over a half, which is 1. Okay, in this example, A is 2, R is, I keep multiplying by 2, so this is also 2. So this guy diverges. Okay, you could say that the sum of the series is infinity if you want, but this diverges. Okay, so this is all sort of a review of stuff from Math 20-1. Okay, now what we're going to do today is introduce basically, or reframe this, I should say, in terms of limits. Okay, so another way that we can look at series is the limit of Sn. So the nth term of a series as n approaches infinity, right? So we're looking at S infinity is equal to L. That's the sum of the series, okay? So that's one way that we can look at it. And then the other notation is this guy over here. It kind of looks like an E, but it's actually the Greek letter sigma. So this is sigma, and it means sum. Okay, now this notation is used quite a lot in math, and if, for example, maybe I'll use this example right here that we just looked at. Let's say I wanted to sum up the first five terms in this sequence. Okay, what I could do to use this notation is I would write this way. Okay, I would say the sum from n equals 1 to n equals 5. So the numbers that go at the bottom and the top are my lower and upper limits on m. And then here I'm going to put the expression for each term in the sequence. So the expression was 5 times 2 to the n minus 1. Whoops, 5 times 2 to the n minus 1. Okay, so what this is going to equal is 5 times 2 to the 1 minus 1 plus 5 times 2 to the 2 minus 1 plus 5 times 2 to the 3 minus 1 plus 5 times 2 to the 4 minus 1 plus 5 times 2 to the 5 minus 1. Okay, so this is what this notation is all about. Okay, so we can use it for finite sums like this one, or we can use it for infinite sums like this one. This would be an infinite sum. Okay, and if we're looking at a series that converges, then we would be looking at an infinite sum. Okay, so for example, find the sum of the following series. Okay, here this series is 3 times, or the geometric sequence rather, would be this over here. This would be the geometric sequence. Okay, 3 times 1/2 to the n minus 1. Okay, so if I'm looking at that being the geometric sequence, well, to get my a value, I have to figure out what is the first term in the geometric sequence. And to do so, I have to say, where does n start? N starts at 1. So a is going to be 3 times 1/2 to the n minus 1, 1 minus 1, because that's where n starts. Okay, so that's 3 times 1/2 to the 0, which is 3 times 1, which is 3. So that's my a value. My r value is this base of 1/2, because that's what I keep multiplying by. That's the repeated multiplication. Okay, so this will converge because the r value, its absolute value is less than 1. Okay, so I can find the sum. Okay, the sum of this series equals a, which is 3, over 1 minus r, 1 minus 1/2. Okay, and that is 3 over 1 minus 1/2 is 1/2. 3 divided by 1/2 is 6. Okay? All right, so on to the next page. Now, for what values of x is the series sum from n equals 0 to infinity convergent, and what is the sum? Okay, well, if we look at this geometric sequence, we can actually write this way, x over 4 to the n, okay? Which means that our a value, since n starts at 0, is x over 4 to the 0, which is anything to the 0 is 1. Okay, and our r value is x over 4. That's the common ratio. Now, if this is convergent, then this r value, its absolute value, must be less than 1. So to converge, the absolute value of r must be less than 1. Okay, so what that tells us is that the absolute value of x over 4 is less than 1. Okay, now with absolute value, we're looking at distance from 0. Okay, so there's two scenarios here. We can either have the absolute value of x over 4 is less than 1, or negative x over 4 is less than 1. Okay, now if we solve both of these for x, we're going to get x is less than 4, or negative x is less than 4. We have to divide this by negative 1, which means x is going to be greater than negative 4. Okay, now if you look at that like on a number line, here's negative 4, here's 4, so x can kind of be anywhere in here. Okay, there's only one value that x cannot be, which is 0. X cannot be 0 in this case, because if x is 0, then a is going to be 0 over 4 to the 0, which is 0 to the 0. And this is an indeterminate. Okay, so what are the restrictions on x? For what values is the series convergent? The values would be negative 4 is less than x, which is less than 4, comma, x cannot equal 0. Okay, now what is the sum? S is a over 1 minus r. So a is 1 over 1 minus r, 1 over x minus 4. Okay, now we need to fix this up a little bit. So we're going to get a common denominator in the denominator between these two terms. And that common denominator would be 4. So this is going to be 1 over 4 minus x over 4 is 4 minus x over 4. And that is, this would be 1 over 1, right? So 1 over 1 times the reciprocal of this, 4 over 4 minus x. So it's this. That would be the sum with this restriction. Okay? And then one more. For what values of x is the series 1, 5 plus x squared, etc. convergent? Okay, well, if we look at this series, if we were to look at the sequence rather, t1 would be 1, t2 is 5 plus x, or 1 times 5 plus x. You could think about it that way because it's t1, or the a value, times this common ratio of r plus x, or 5 plus x rather, what am I saying? T3 equals 1 times 5 plus x squared. So now I've multiplied by 5 plus x again. Okay, if I were to do this again, T4 would be 1 times 5 plus x cubed. I'd multiply by 5 plus x a third time, another time. Okay, so our a value is 1, and our r value is 5 plus x. Okay, again, for convergence, the absolute value of r must be less than 1. Okay, so r is 5 plus x, must be less than 1. Now again, 2 scenarios. Positive 5 plus x is less than 1, or negative 5 plus x is less than 1. Okay, now if I solve this one, subtract 5 from both sides, I'm going to have x is less than negative 4. Or here I have to do a little bit more work. So negative 5 minus x is less than 1. I'm going to add 5 to both sides. So I'm going to get negative x is less than 6. And again, when I divide by negative 1, the direction of the inequality flips. So x is greater than negative 6. Okay, and so if we put these together, if you look on a number line, right, here's negative 6, here's 4, negative 4 rather, x has to be greater than negative 6, but less than negative 4, so it can be anywhere in here. Okay, so negative 6 less than x less than negative 4. Those would be the values of x for which that series would converge. Okay, so that's all for today. I will see you.